Hello, welcome back. This is Trade Digital Academy, Nuclear Physics Part 1. Uh, Today we will see about constituents and stability of matter. The objective of this lesson is the student will be able to understand the basic structure of atom, describe the composition of the nucleus, explain nuclear force and how they hold the nucleus, especially how they play a role in the stability of the nucleus. Define the binding energy and the binding energy per nucleon. We will discover what's binding energy and the binding energy per nucleon and how they play a role in stability of the nucleus. Also, we will understand stability of the nucleus. So don't forget to stay with me up to the end of this lesson. Data starts from structure of matter. As we know, all matter is made of an atom. So it is a composed of atoms, and the atom is a very small and teeny with a size of around 1 angiometer, which is 10 raised to minus 10 meter. And it contains two parts. The outermost part is electron, which is negatively charged, and the inner one is the nucleus, which is also contain two particles, proton and neutron, where proton is positively charged and neutron is neutral, so we can say a nucleus is positive charged. So when we come to atomic nucleus, as we said that nucleus is as the inner part of the atom, and atomic nucleus is very thin and small in size. It is compared to atomic nucleus. So it is ranges from 1 to 10 femtometer, which is 1 times 10 raised to minus 15 meter to 1 times 10 raised to minus 14 meter. So it is extremely dense compared to the atom, and it contains nucleons, a proton and neutron, which is discussed earlier. So atomic nucleus size, the largest atomic nuclear size is 10 femtometer. So what's the nuclear force? In come to nuclear force, before that we said that nucleus is composed of proton and the neutron, and the protons are positively charged. So these positively charged exert a force on each others. So there are two types of force in atomic nucleus. These two forces are strong nuclear force and Coulomb force. The strong nuclear force is attractive and very short range. It is attractive force between proton and neutron, and it is very short range, and it holds these nucleons together. Whereas Coulomb force is a repulsive force between the proton, and it is a long range but weaker in a nucleus. So the stability of the nucleus is based on the balance of these two forces. So what makes nuclear stable? If we say it, proton and neutrons are only particles in the nucleus. These two particles play important role in the stability of the nucleus. So stability of nucleus depend on both number of proton and the number of neutron it contains. And the continuous line drawn through the center of the band is called stability line. Let's see the stability line. The stability line, when we plot number of neutron versus number of proton, for the lighter nuclei, number of neutron equals to number of proton provides stability. So a lighter nuclei with equal number of neutron in the proton is stable. But as atomic nuclei increase in size, the number of neutrons must be greater than number of protons to overcome the repulsive force between proton and proton. So the stability curve carved up toward largest number of neutrons than number of proton. Good. So if we say this one, what makes more important when we talk about stability, there should be some energy, which we call binding energy. The energy required to break a nucleus into its component, proton and the neutron, or the vice versa. And indicates the nuclear stability. Binding energy also plays major role in nuclear stability. So highest binding energy will give us more stable nucleus. So this binding energy comes from mass defects, which we can say change of M or delta M. And the binding energy is equals to this mass defect times speed of light square or delta M times c square. So what's a mass defect? If we say so, we should have to know mass defect. Mass defect is the mass difference that comes from the sum of nucleons mass or the consequence of nucleons mass from it is nuclear mass. So nuclear mass is less than the sum of its constituents nucleon masses. So this difference is called mass defect. And the mass defect will be equals to mathematically number of proton times mass of proton plus number of neutron times mass of neutron minus mass of nucleus. So that binding energy is equals to number of proton times mass of proton plus number of neutron times mass of neutron minus mass of nucleons, the whole times speed of light square will give us binding energy. So when we come to binding energy per nucleon, what does that mean? Binding energy per nucleon means it is the average energy required to remove a nucleon from the nucleus. The same analogy to atomic ionization energy. What is atomic ionization energy? Is the energy required to separate one electron from atom. So, the same way, the average energy required to remove one nucleon, whether it's a proton or neutron, from its nucleus is called binding energy per nucleon, or we can simply say BAN for short abbreviation. So, larger binding energy per nucleon will provide greater nuclear stability, and it is typical value ranges from 6 to 9 mega electron volts, which is almost around 8.8 mega electron volts. We get the maximum value or the stability curve. So the nuclear binding energy is much greater than atomic binding energy. Atomic binding energy is in the range of in the order of electron volt scale, whereas nuclear binding energy is in the order of mega electron volts. So there is a very big difference. That is why strong nuclear force play major role here. So when we come to see binding energy per nucleon curve, as you have seen from the graph, for a mass number, a smaller mass number like hydrogen, helium, we can see that binding energy per nucleon is increasing in proportion to mass number. But we can see some zigzag or up down around lithium and some nucleus. and it's increased up to the maximum point, which is where the maximum stability or to the stability region, which is iron 56. So the lighter nuclei combine together or fuse together to upgrade themselves or to become more stable and come to near to stability region. So we can see it's a fusion region. And after the stability region or after iron 56, we see that the constantly or nearly smooth curve, but it is below iron 56. So in this we can see a very large mass numbers, up to large mass number. These largest mass numbers splits to one or more nuclei, and they also will try to increase their binding energy per nucleon and more stable toward iron 56. And this is called, the region is fusion region. We will see in detail about fusion and fission in the next video lesson. So let us come to about nuclear energy level. When we talk about nuclear energy level, we know that nuclear energy is quantized, which means it has discrete energy levels. So we can categorize as excitation and de-excitation energy. The excitation energy is energy of nucleon where it is maximum value occurred after the interaction of nuclear with particle or after absorption of particle. And since a nuclear cannot stay longer excited, it will be excited by emitting gamma radiation and return to ground state energy. So from this diagram, as you have seen, first a nucleus is as a ground energy level. Then after some interaction with neutron or another particle, it will become excited in the highest energy level, with energy is increased from background energy to first excited, second excited, or the maximum stage we call excitation. Then after excitation, nuclear will not stay longer with excitation energy, so it will emit gamma radiation and be excited to background energy states. So this is all about nuclear stability and constituents of matter, binding energy per nucleon we have seen, and the aim of the objective of this lesson is discovered here. So try to answer these questions and you will see how you understand the objective of this lesson. If you have any question or any unclear idea, don't forget to write it under the comment. Till that, have a nice time. Don't forget to subscribe for getting new videos as soon as it's uploaded. Thank you very much. Have a nice time.